Hazardous locations are defined in the National Electrical Code, specifically Section 500.5, as locations where fire or explosion hazards exist due to flammable gases or vapors, flammable liquids, combustible dusts, or ignitable fibers or flyings. These substances must be present in the air in quantities sufficient to produce explosive or ignitable mixtures. To elaborate, a hazardous location is not simply a place where a flammable substance is stored. It's a location where the flammable substance is present in the air at a concentration high enough to create a risk of fire or explosion. This concentration is often referred to as being within the explosive limits of the substance. These limits define the range of concentrations in which the substance can ignite and cause an explosion. If the concentration is too low, there isn't enough fuel to sustain combustion. If the concentration is too high, there isn't enough oxygen to support combustion. Only when the concentration falls within the explosive limits does a hazardous condition exist. The National Electrical Code classifies hazardous locations into different classes, divisions, and zones based on the type of hazardous material present and the likelihood of its presence in an ignitable concentration. Understanding these classifications is crucial for selecting the appropriate electrical equipment and wiring methods for a particular location. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Examples of Class 1 locations include petroleum refineries, gasoline storage areas, and natural gas processing plants. Class 2 locations are those where combustible dust is, or may be, present in the air in quantities sufficient to cause a fire or explosion hazard. Examples of Class 2 locations include grain elevators, flour mills, and coal preparation plants. Class 3 locations are those where ignitable fibers or flyings are present, but not likely to be in suspension in the air in quantities sufficient to produce ignitable mixtures. Examples of Class 3 locations include textile mills, woodworking plants, and cotton gins. Within each class, there are divisions or zones that further define the likelihood of the hazardous material being present in an ignitable concentration. Division 1 or Zone 0 locations are those where the hazardous material is present continuously or for long periods of time. Division 2 or Zone 1 locations are those where the hazardous material is likely to be present under normal operating conditions. Zone 2 locations are those where the hazardous material is only likely to be present under abnormal operating conditions such as an accident or equipment failure. The National Electrical Code requires that electrical equipment installed in hazardous locations be specifically designed and approved for use in those locations. This equipment is designed to prevent ignition of the hazardous material, either by containing any sparks or arcs within an enclosure or by limiting the surface temperature of the equipment to below the ignition temperature of the hazardous material. Equipment for hazardous locations is typically marked with the class, division, or zone for which it is approved, as well as other information such as the type of hazardous material it is designed to be used with. It is important to select equipment that is appropriate for the specific hazardous location in which it will be installed. In addition to selecting the appropriate equipment, it is also important to follow the wiring methods specified in the National Electrical Code for hazardous locations. These wiring methods are designed to prevent the spread of fire or explosion from one area to another. Common wiring methods for hazardous locations include the use of rigid metal conduit, explosion-proof fittings, and intrinsically safe circuits. Rigid metal conduit provides a robust enclosure for conductors, preventing the escape of sparks or arcs. Explosion-proof fittings are designed to contain any explosion that may occur within the fitting, preventing it from spreading to other areas. Intrinsically safe circuits are designed to limit the energy available in the circuit to a level that is too low to ignite the hazardous material. The National Electrical Code also contains requirements for the installation and maintenance of electrical equipment in hazardous locations. These requirements are designed to ensure that the equipment continues to operate safely over time. Regular inspections and maintenance are essential to identify and correct any potential hazards. These inspections should include checking for damage to equipment, loose connections, and signs of corrosion. It is also important to ensure that all equipment is properly grounded and bonded. Grounding and bonding help to prevent the buildup of static electricity, which can be a source of ignition in hazardous locations. The National Electrical Code is a complex document, and it is important to consult with a qualified electrical professional when designing, installing, or maintaining electrical systems in hazardous locations. A qualified electrical professional can help to ensure that the system meets all applicable requirements and is safe to operate. The requirements in Article 500.5 of the National Electrical Code are not the only considerations for electrical safety in hazardous locations. Other articles in the NEC, such as Article 501, 502, 503, 505, and 506, provide specific requirements for different types of hazardous locations. In addition to the National Electrical Code, there may be other applicable codes and standards, such as those issued by the Occupational Safety and Health Administration, or OSHA, and the National Fire Protection Association, or NFPA. These codes and standards may provide additional requirements for electrical safety in hazardous locations. Understanding the definitions and classifications within the National Electrical Code and other related standards is paramount to ensuring safe electrical installations. Incorrectly classifying a location or using inappropriate equipment can have severe consequences, leading to fire, explosion, injury, or even death. Therefore, continuous education and adherence to the latest codes and best practices are vital for anyone working with electrical systems in environments where flammable substances are present. Remember that the presence of a flammable substance alone does not automatically define a location as hazardous. It's the potential for that substance to be present in the air in sufficient quantities to create an explosive or ignitable mixture that triggers the hazardous location designation and the associated safety requirements. The NEC definition clearly states this requirement. Therefore, proper assessment of the environment, potential sources of leaks or releases, and ventilation are essential factors in determining whether a location should be classified as hazardous. The NEC classification system allows for a tiered approach to safety, with stricter requirements applied to locations where the risk of a hazardous atmosphere is higher. This approach helps to ensure that electrical systems are designed and installed in a manner that is commensurate with the level of risk. Remember, the definition of hazardous locations, as described in NEC Section 500.5, plays a vital role in electrical safety. It serves as the foundation for understanding the requirements for electrical installations in environments where fire or explosion hazards exist due to flammable materials. By properly identifying and classifying these locations and adhering to the applicable codes and standards, engineers, electricians, and safety professionals can help to prevent accidents and protect lives. The National Electrical Code is updated regularly to reflect changes in technology and industry practices. It is important to stay up to date on the latest edition of the NEC to ensure that your electrical systems meet the most current safety standards. This information is for general guidance only. Always consult the latest edition of the National Electrical Code and with a qualified electrical professional for specific requirements. Electrical work in hazardous locations should only be performed by qualified and experienced personnel.